So the next thing we're going to look at is a histogram of this data. Remember, a histogram is kind of like a bar graph. There's also oftentimes questions about where do we graph this 10? There's a stray number 10 that's here. Should that go here between 0 and 10 or here between 10 and 20? Here's typically where I think it makes more sense. I think 10 should be grouped with other numbers that start with 1, like 11, 12, 13, and 14, which would be in this bar that I've already kind of drawn right here. Could you put it with the 0 through 10? Well, if you do it with this, then you're kind of putting it with like numbers like 2, 3, and 6, single-digit numbers, and you have this row 10 that's out here. So I personally think it makes more sense to put the bar here with the other numbers that start with a 1, like 11, 12, 13, and 14, than it does here with like 5, 6, and 7. So we have one number that's in the teens, we have two numbers in the 30s, we have four numbers in the 40s, we have, looks like 5 numbers in the 50s, and we have one number in the 60s. Again, to me it makes more sense to group the 60 over here on this bar here than put it with other numbers that are in the 50s up here. Do any numbers appear to be outliers based on the graph? Well, I don't want you to use the formula. I'm just saying, do any points kind of stick out as being removed from maybe the rest of the majority of the data? And to me, I would say that this bar right here, it's separated from the rest of this graph, and there's a difference of 22 between it and the kind of the next number. So I think that 10 kind of appears to be maybe an outlier. We could check it using the formula, but just by inspection, that appears to be a point that kind of sticks out. The mean of this data is what you get if you were to add all these numbers and divide by how many there are. If you were to actually do that with this set of data, you would find that the mean is 45.8, which would put the mean kind of in this area right over here. The median is the middle number, and you'll notice I've drawn a line right here. We have 1, 2, 3, 4, 5, 6 numbers that are smaller than that, and we have 1, 2, 3, 4, 5, 6 numbers bigger than that. So 48 is the median in this case. So the mean and median are pretty close, but the median is a little bit bigger. In our second set of data, we have another histogram, and I've done kind of the same thing with this graph as well. You'll notice that we have a couple of these questionable points again. We have a 200 that's kind of here. We also have a 300. I've grouped the 200 with the rest of its fellow 200 numbers. There are 6 of these 200 numbers, which is why I've kind of graphed it on this set of bars. 300, if I include it with these other numbers that are in the 300s, that gives us 3 numbers that are in the 300s. So that's why I have this bar as being 3 high. What shape is this histogram? Well, I've skipped that on the previous question here. On this graph, if you were to imagine like throwing like a blanket or a tarp over this, if these were kind of like boxes that were stacked high, you would see kind of a graph that would do kind of something like this. And if you recall on the front side of the worksheet, this graph here has taller kind of values on the right side, long tail on the left side. If the long tail is on the left side, we call that graph left skewed. However, on our graph that we just looked at a moment ago, this graph here is kind of the opposite. Tall bars are on the right side, longer tail is kind of on the right side, so that would kind of indicate more of a right skewed graph like we saw right here. And that's what we have in the second case, a right skewed graph. Do any numbers appear to be outliers? Again, do any bars seem to be removed from a majority of the data? To me, we've got 2 bars that kind of look like that. I would say this one and this one both are, and that would kind of lead me to indicate that probably 711 and 912 are both outliers in this case. Again, we could check it using a formula, but just kind of off the top of my head, I would say that those appear to be outliers. You can again find the mean by adding all these numbers and dividing by how many there are. In this case, the mean is approximately 348.7 if you were to do that calculation. In the middle number, again, I've drawn a line here. You'll notice we have 1, 2, 3, 4, 5, 6, 7, 8 numbers smaller than this where this line is at, and 1, 2, 3, 4, 5, 6, 7, 8 numbers bigger, so 293 is your median. A little bit bigger of a difference this time between the mean and the median, because oftentimes these numbers are pretty close. So what relationship do you notice between the shape of a histogram and the presence of outliers? Well, in our first problem, we noticed that the graph was left skewed and we had an outlier that was kind of over here on the left side. On our second graph, you'll notice we have a couple outliers here on the right side, and that indicated a right skewed graph. So a relationship that you might notice is that left skewed graphs typically have outliers on the left and right skewed graphs have outliers on the right. If you actually had outliers on both sides, you would probably still have more of a symmetric looking graph like we kind of talked about over here. You might just have a kind of a stray bar that might be over here and maybe a stray bar that's over here. What do you notice about the median and mean when data is left skewed? Well, when our data was left skewed, which we had in our first example, the mean was 45.8, the median was 48, kind of indicated that the median was a little bit bigger than the mean was, or you could say vice versa, the mean was smaller than the median. And on the right skewed graph for letter K, kind of the reverse relationship. The mean was bigger than the median, and that's typically the case on a right skewed graph. So wherever the tail is, that kind of indicates where the mean is going. So if you have a left skewed graph, the mean goes further down the left side of the tail, so the mean is smaller. When the graph is right skewed, the mean kind of goes further down the tail, and the mean ends up being larger than the median.